It's something that's convenient for the folks who aren't here, but not great if you don't ask questions while we're doing this. We're looking at 8-3 trig ratios. Objective to use the sine, cosine, tangent ratios to determine side lengths and angle measures in a right triangle. Now here's the deal. Sine, cosine, and tangent are names of ratios. Their specific name lines up the ratios themselves. Okay, so just make sure as you're looking that over that if you've got a question on how I know I'm doing stuff, ask, because most of the time it's just how the ratio is defined. Now, today's like the only day you'll be given the ratio and expected to do work in it. Other than that, what'll happen is you'll determine which ratio to use based on the information provided in the problem to solve for what's missing. Now, it's always been that a math section, like a section out of a chapter, has been, not a big deal. We're just going to move on. How much of the chapter is important based on this? This section is simply the most important section in the chapter. Okay? Not understanding this prevents you from understanding the rest of the information I'm going to present over the next 2 days for section 8.3. Section 8.4 and section 8.5. So what I'm really saying is don't get the ratio relationships, don't pass this chapter test, period. It's that direct. It's not impossible, but don't just go, oh, it's not important. It's the most important section in the entire chapter, okay? Now, trig ratios. Trig ratio is a ratio of the length of two sides of a right triangle. Trigonometry is from the ancient Greek language and means measurement of triangles. 3 basic trigonometric ratios. Sine, it's pronounced sine. I know on your calculator it looks like sin, S-I-N, but there's nothing biblical about it. Okay, cosine, cos, and tangent, tan. Now, these are on your calculator in that order. And remember, I was kind of a crazed individual about making sure you have your own calculator. Got to have it out, and I would pull it out today. I'm going to use it for like 4 or 5 problems today. But let's talk about these first. When I was my instructor came up with this really cool mnemonic device just so I could remember what's going on. Because my keys in my calculator had sine, cosine, and tangent right in front of me, he had this story. Oliver and Ollie have huge appetites. And I was like, remember that, I'd write down Oliver and Ollie have huge appetites. And sine is opposite over hypotenuse. That's the ratio that sine represents. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And I thought about this for a long time, and I used it for years until I started teaching it. And then I was like, I'm a swimming coach. I don't make up stories. And right before you go swimming, you take your toe and you put it in the water. You soak a toa, right? So we got so, opposite over hypotenuse, ka, adjacent over hypotenuse, and toa, tangent, opposite over adjacent. Now the benefit I find with that is that you don't have to write the whole thing out to use single ones as we do this. But it doesn't matter how I look at it. Maybe perhaps it'll be how you look at it. But if you get stuck, I'll just say, hey, remember I'm a swimming coach. Okay? And you soak a toa before you go swimming. Okay? So let's talk about how we're going to use these. Now, what's a sine mean? Sine, if I put it in my calculator with an actual angle value, returns the ratio of the opposite side to angle A over the hypotenuse. It's a ratio that's returned. Okay, if I put the cosine of an angle in, if I take the adjacent side and divide it by the hypotenuse, that's the same value. Okay, if I put the tangent of an angle, actual angle, into my calculator, it returns the opposite divided by the adjacent sides of that same angle. Okay. Now, we'll be working with things today without angle measures. So we'll be able to set them up and do them pretty much calculator free, but I'm going to show you how to use your calculator as well in some instances. But you got to have angle, this must be an angle value. A has to be an angle value, okay? So I want you to make sure you know that. But even if you don't have it be an angle, you can figure out the ratio, or at least the which side's over which side, based on the name of the ratios provided. So if I say, hey, I want you to find the sine of A, you're going to go and stand on A, and it's all relative. I'm going to sit there at A, and the side opposite A and the hypotenuse, this is A over C. Now, I got a lot of people going, Bloom, what's the deal? Okay, the hypotenuse is always opposite C. Okay, in this case, because it's the right angle. The hypotenuse is opposite the right angle. In each instance, the hypotenuse in this problem, if the hypotenuse and the triangles will never change their position, okay? The opposite and adjacent, depending on the angle I'm working with, will. So keep that in mind. So now, cosine of A, adjacent over hypotenuse, B over C. Tangent of A. Well, tangent of A. Tangent is opposite over adjacent, so I've got A over C. Okay, now I want you to be able to keep this in mind as I'm looking this over, because it is specific to the acute angle I'm working with. So if I'm working with a different angle, like B, and by the way, we'll always work with B or A, the acute angles. I look at the sine of B. Okay, now opposite angle B is side B over hypotenuse, because sine is SOH, S-O-H. Ca is, adjacent over hypotenuse, ca. So cosine. So adjacent hypotenuse, A over H, or in this case, excuse me, C. And then I've got tangent of B. Tangent is opposite over adjacent, which is B over A. Now I know I didn't have a spot for this written down for y'all, but I felt as I was going through notes earlier in one of my classes, I need you to see a bunch of iterations of what I'm doing with this. So this is my example to prep you for the next 35 problems we're going to do. And people like get big eyes, and it's like, no lie, 35, it'll be done in like 12 minutes. Okay, they're quick. So now, are you okay? It's all about the position where I am in relation to the rest of the triangle if I'm talking about a particular angle. And we're always finding sine, cosine, and tangent on the acute angles on the triangle, okay? Not the right angle. So now, with that said, I have point A right here. This is angle A. I would like you to find the sine, cosine, and tangent of angle A in this first triangle. So please go ahead, find the sine, cosine, and tangent. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Okay, it's all about position. Okay, go ahead, give it a try. And I always have people who like blow this off and not try. I need you to actually try it. Okay, because when you try something, we start getting a better understanding of what we're doing wrong than you just watching me do it. So give it a try. You're catching up. You can take notes today and be able to do that split. You don't need this to be successful on the day. Okay, let's do that today. All right. All right, so let's check this out. The sine of A. Remember, sine is opposite over hypotenuse. Hypotenuse is always opposite the right angle. So it's 4 over 5. The cosine of A is the adjacent over hypotenuse, 3 over 5. The tangent is the opposite over the adjacent, 4 over 3. Are there any clarifications? Now it's very specific. You can't say 3 over 4 because that would be the tangent of B, and we're working with the tangent of A. They're very, very structured this way. Are there any questions on the sine, cosine, tangent for angle A? Okay, I'm thinking that the sine, cosine, tangent for angle R, and that's in this other triangle, will go faster that way. Go ahead, give it a try. Sine, cosine, and tangent for angle R. Go ahead, give it a try. Okay, remember, it's all about position. If I'm on angle R, I'm looking at opposite over hypotenuse, 8 over 10. Now, I know some people are like, boom, reduce it. Right now, I'm happy you got the right numbers in the right spots. I'm not worrying about reducing right now. In the future, I will, okay? But right now, I just worry about the numbers. The cosine of angle R, adjacent over hypotenuse, 6 over 10. The tangent of angle R is opposite over adjacent, 8 over 6. Are you okay with those? Okay, feeling better? Now, I purposely picked the triangles I did, and I want to make sure that you are aware. They were similar triangles. R is the same angle value. It'll return the same ratio. Check it out. 4 divided by 5 is 0.8. 8 divided by 10, 0.8. 3 divided by 5 is 0.6. 6 divided by 10, 0.6. 4 divided by 3, 1 1/3. And 8 divided by 6, 1 1/3. Same ratio when the triangles are similar. Doesn't matter. Works all the time. Okay. Now, we're going to find that trig ratio again here with a different triangle. Now, I have you do A, B, and C, and D, E, and F. Those folks at home, after I have the folks on campus do A, B, and C, I'm going to have them compare with people next to them. You won't have that option, so compare with my work after you're done. Okay, so turn this off and then check it out. You guys go ahead, do A, B, and C. See what you know. And if you got questions, ask as I'm walking around. It's going okay. Remember, what do you do before you go swimming? You soak a toa. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. All right, so here it is. Did you have time to peek at somebody else's? Why don't you do that right now? Say hi, peek at somebody else's before I move on. Say hi, peek at them. See what up? See what up? Faith, is it going okay? Promise. Okay, go ahead. Yes, go ahead. Do the formative on your own. People will get a note about it today. Okay. It's wide open. I haven't checked them yet. Okay, so here's the deal. Sine of A. I'm standing at A. The sine is 12 over 13. The cosine is 5 over 13. The tangent, opposite over adjacent, 12 over 5. Okay? You doing all right with those? So now, if I switch to go to B, I'm going the sine is opposite over hypotenuse, 5 over 13. The cosine's adjacent over hypotenuse, which is 12 over 13. The tangent's opposite over adjacent, which is 5 over 12. Are there any questions regarding those? Now, were you guys aware that in a right triangle, the two acute angles sum to 90 degrees? Did you know that? I want to point something out. It's called cofunction. It's nothing that you learn really or need to learn as a geometry student, but I'm always asked about it because did you notice that the cosine of A and the sine of B is the same value? Did you notice that the sine of A and the cosine of B are the same value? When two angles add up to 90, their sine and cosine respectively are the same value. It's called cofunctions. So if I have the sine of 20, Okay, if I knew the sine of 20, the cosine of 70 is the same value. And if I knew the sine of 4, the cosine of 86 is the same value. So I want to make sure that you start seeing that, because I'm always asked, people always ask, why are they the same? It's because of their cofunction, okay? It's directly related to their cofunctions. Now, that's something I expect my pre-calc kids to know backwards and forwards. You guys, it's a nice little tidbit to know, okay? Now, with that said, I have on page 18, 10 problems. On page 18, 10 problems. You are being asked to find one of the ratios with respect to one of the angles in each one of those 10 problems. It should take you less than 5 minutes to do all 10 of them, okay? Actually, less than 3 minutes probably. Go ahead, find the particular ones you've been asked to find. Once you find them, I kind of expect you to reduce, but I'm not going to like hammer you on that today. But find the original, put the original values down, and then put the reduced values down, just in case you mess up on the reduction. Yeah. You may. Remember, this is still part of notes. I want to make sure we get this before we go on, because not getting it is a drag. And as I'm walking around, ask questions. This is our opportunity to check things out. The first thing you should have at your top of your page is what you do before you go swimming. SOHCAHTOA should be up there. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. SOHCAHTOA. SOHCAHTOA. He's the silliest math teacher on the face of the planet. He talks about going swimming and dipping his toes in the water, and he soaks the toe up. What's up with that? Remember, you will not need a calculator to do these ratios unless you're just reducing. Okay, this is all about the sides, nothing special, all about the sides. These are side ratios. Okay, you ready? First 6. See where we're at. Want to make sure if you have any questions, you get answers to them right now. Not tomorrow, not later tonight, not at the end of the lesson. We do that now. Those folks at home, I apologize, but I'm not interactive as a video. But if you have questions, make sure you start paying attention to what we're doing and how we're setting things up. In 1, the tangent of z. Tangent is opposite over adjacent. So I go opposite over adjacent. That's where I went 21 over 28. Cosine of c in 2. Cosine of c. Cosine is adjacent over hypotenuse. That's where 16 over 34 came, and I reduced from there. Sine of c. Sine of c. Opposite over hypotenuse. That's where it's 28 and 35. Okay, the tangent of x. I'm at x. Tangent, opposite over adjacent, 32 over 24. Cosine of a. I've got adjacent over hypotenuse is 30 over 34. And the sine of a is opposite over hypotenuse, which is, sine of a, I got to get that, which is opposite over hypotenuse, and that's 32 over 40. And that's where those came from, 32 over 40. Are there any questions about these? How I'm doing it? Remember, sine, cosine, tangent, specific names of ratios. Sine means I'm doing a ratio of the opposite side over hypotenuse. Cosine means I'm setting up a ratio of the adjacent side over the hypotenuse. Okay, tangent means I'm setting up a ratio of opposite side over the adjacent side, and it's all relative to the angle I'm working with, and it's the acute angle I'm working with. Okay. Are there any follow-ups? Okay, let's go flipping back to page 16, please. Right at the bottom of 16. I need to find out if your calculator's in the right mode. Okay, if your calculator's in the right mode. It's dangerous because you can know how to do stuff and then go to your calculator and it's calculating using the wrong system. Okay, I want degree versus radians. And your calculator, the graphing calculators normally come already set up as radians. So if you have a graphing calculator, this is how you know. Put in sine of 30. It should be 0.5. Okay, if it's not 0.5, you didn't change it last week, you need to change it right now. Not a 0.5, right? Okay, so find mode. And even if you have it right, I want you to find mode. It's to the right of your yellow button. You're going to find your mode button. Okay, you got the mode, you push it. You arrow down, 3 units, and you get to radians. Arrow to the right 1, you get degree. Select degree, hit enter. Now you are in degree. And all it really comes down to is your calculator will function normally everywhere else except for sine, cosine, tangent, trig function stuff. It's going to assume an argument of 0 to 360 or higher, for your degrees of an angle. Okay. The other one was a different version of measuring in radians. Okay. And we don't use that in geometry. Know that if you borrow one of my calculators in class, you have to know how to do this because my pre-calc students are using my calculators too, and they switch from degree to radian, problem to problem, depending on what they need. Okay, so you've got to know that you just need it in degree, and you've got to know that you need to sit down with the calculator right away. Anytime you take an ACT, SAT test, they will clear that calculator the moment you walk into that test room, and it is automatically into radian. You have to know that because you have to switch it back and forth depending on what you need for your test. Okay, and that thing is in degree. All right, so know that. Now, what I want you to do now is using your calculator, plug in cosine of 60. Plug in tangent of 45. Plug in cosine of 89 and sine of 89. And record, and by the way, the custom dictates that we record to the 4th digit after the decimal. That's the 10,000th position. The 10,000th position is what we're doing that with. So make sure your calculator is in the right mode and you'll be able to find your values. Are you okay with those values that I found? Are there any questions? Now, if it's 0, notice how I padded zeros out to the 4th digit. That's the expectation if you go out to the 4th digit, even if it's 0, if it doesn't show up in your calculator, that it's there. Okay, you can set your float to go out to 4 in your graphing calculator, or you can just know better. Okay, for folks that don't have graphing calculators, Max Steel, this calculator has something in the bottom right above your up arrow that says either DRG, RAD, which is rad, okay, or it goes, there's a third one, I think it's hex decimal. GRD, gradient, okay? You want to do your DRG and always be it in radians, degrees. So you want D and deg. It'll come up at DEG on your calculator. You're doing it right then too, okay? And that one is just in your backpack that'll switch, okay? Now, the next thing, top of page 17. I want you to find the three missing sides on these 3 triangles, and I want you to know if it is a right triangle with 2 sides, use a squared plus b squared equals c squared to find the 3rd side. So figure it out, see what's up, go. While you guys are doing that, I'm going to be handing back your chapter 7 test. We're going to talk about that, and those folks that need, well, I'm not really going to talk about it. You guys are going to get this information back, and those people that need to will be taking it and going from there. Okay. Okay, there's 2 ways of looking at this because I really emphasized Pythagorean triples last week. Okay, the basic is 3, 4, 5. Okay, but other ones are 5, 12, 13. This one's 13 right here for x, so it should happen. That would be 13. It makes sense. Any multiple of Pythagorean triple works. So when I'm looking at 12, not 12 in B, but look at C for a second. Any multiple of that would work. Thank you, dear. I'd be looking for it soon, I'm sure. Okay, thank you. Okay, any multiple of that would be 24, 26, and I'd be looking at 10. That would be missing. So that's a multiple of 5, 12, 13, 10, 24, 26. Okay, but if you didn't know, you didn't recognize Pythagorean theorem, we'll find it, won't it? Okay, now this one, remember the basic was 3, 4, 5? 4 goes into both of these, 12 and 20. 3 and 5, this has to be 4 if it's a right triangle. Okay, which is 4 times 4, which is 16 in this case. It's a multiple of that 3, 4, 5. So that's what I look at when I do stuff, and I also make a bunch of problems for practice off of those. Okay, and I haven't been secretive about it. So keep that in mind as we're looking those over, okay? That's it for notes today, all right? Your assignment is page 18, page 19, and page 20, all 3 of those pages in their entirety. They will be completely done before you walk out of here today, okay? They are fast. And all you're doing is ratios. You will need your calculator if you're asked to write the ratio of a cosine of 30 or cosine of 50 or cosine of 10 or something like that. Any other time, you will not need your calculator at all. What I need you guys to do is correct your, I shouldn't say correct, look over your test. The first thing you should do is take off your note card. I do not want them. I will not have them at the end if you don't keep them yourself. Okay? Your job is to have your materials for your success in June. So make sure you put on the top of this note card, Chapter 7 test. Okay, so you know that it went with the Chapter 7 test, so you won't have to guess at it later. Take it off, put it away someplace you'll know. If you have questions regarding the test, ask me. If you don't, fantastic. The people who scored below 75 is your choice to do a retest. I do not make you do that, but please know that the Chapter 7 test is your best chance for getting a retest going. Okay, I will collect those in about 10-15 minutes if you got questions. Please don't share it with other people who haven't taken it because that's not fair to you. Okay, and that'll be where it's at. I will collect these in about 10 minutes. Okay, do your work today. Make sure that your online stuff, your Schoology stuff, your formative in Schoology you were assigned on Friday is done. You may do it again to be get a better score on it, and know that that is going to be coming towards the quiz that we have this Friday. Okay, we have a quiz this Friday regarding that information, more information that's got a little bit more teeth in it. Okay, all right, super, thank you.